tranquil seas, blue skies, and oil. What's oil doing under the ocean?
Did somebody say oil? It's the United States of America, baby. Have you ever wondered how submarines are able to submerge and float? We'll be talking about the USS Virginia class submarine today. The main principles we'll be talking about are density, buoyancy, and weight. Average density can be summarized as density equals mass divided by volume. Buoyant force can be defined as buoyant force equals density of the liquid multiplied by gravity multiplied by the volume of the object. And the weight of the object equals mass multiplied by gravity. There are a few basic principles that everyone should know. To start with, if the density of the submarine is larger than the density of water, then the submarine submerges. If its density is less than the density of water, the submarine floats. So this can be restated as if the buoyant force is larger than the weight of the submarine, then the submarine floats. If the buoyant force is less than the weight of the submarine, it sinks. And if the buoyant force equals the weight of the submarine, it remains suspended at the same depth. So now we will talk about the ballast tanks. To control its buoyancy, the submarine has ballast tanks that can be filled with seawater and or air. In all three cases, the volumes of the ballast tanks are the same. In the left image, the tank is filled with air. Air is less heavy than seawater. Using the density formula, the resulting density of the submarine will be less than that of seawater, as air is lighter in mass than seawater. Therefore, the submarine floats on top of the seawater. In the middle image, seawater is pumped into the ballast tanks to replace the air, making the density of the submarine greater than the density of seawater, and hence the submarine submerges. The mass of the submarine increases because seawater is heavier than air, due to seawater being denser than air, shown by the relationship on the top right. The right image shows the submarine ascending to the floating position by pumping air into the tank, making the submarine lighter.
Hello, General. This is US President Joe Biden speaking. We found a repository of oil beneath the ocean, and it's your job to collect it. By the way, it's in an unknown liquid. We now have to solve the problem of the buoyancy force needed to make a nuclear submarine float, the USS Virginia class, in an unknown liquid. The density needs to be found, as the density of the unknown liquid has to be found. The mass of the submarine is 730 million kilograms, and the submarine's volume is 18% submerged in the unknown liquid. The length of the submarine is 115 meters, and the radius of the submarine's beam is 5 meters. The mass is restated. If you look in the bottom left corner of the slide, the three principles are restated, as we'll be using these three principles and formulas again in this problem. The first thing to do is find the density of the unknown liquid. To find the density of the unknown liquid, we have to use the weight of the submarine and buoyancy force formulas to find the density of the unknown liquid. The first things first is that we define the volume of the submarine. We will consider the volume of the submarine being as if it is a cylinder. And a cylinder's formula is pi multiplied by radius squared multiplied by height. If 5 meters and 115 meters, the length and the radius of the submarine, are put into this formula, we get that the volume of the submarine is 9,032.08 meters cubed. Once the buoyancy force and the weight of the submarine are set equal to each other, we can cancel out the gravities and divide the mass of the submarine by 18% of the volume of the submarine. And if you plug in the mass and the volume of the submarine multiplied by 0.18, we get that the density of the unknown liquid is 4,490.17 kilograms per meters cubed. Now that we know the density of the unknown liquid, we can find the buoyancy force acting against the USS Virginia class submarine. Buoyancy force is defined as density multiplied by gravity multiplied by volume. Volume at 18%, 18% of the submerged volume is 1,625.7744 meters cubed, and the gravity on Earth is 9.8 meters per second squared. And the density of the unknown liquid that we found is 4,490.17 kilograms per meters cubed. This multiplying these three variables together, we get that the buoyancy force is 71,540,033.68895 newtons. Congratulations, we found the buoyancy force and the density of the unknown liquid. My name is Juvraj.
And my name is Arman.
And these are references.